Good afternoon everyone, my name is Mark Jenkins for Kingspan Installation. I'm product manager for the tech building system. Been with Kingspan just over 12 months, 18 months now. Prior to joining them I used to actually work for one of our delivery partners, so actually involved in the other side of the fence, so experience of design, engineering and the erection of the kits on sites as well. So the idea is to introduce you to the tech building system or SIP panel construction for those who've have never been involved with SIP panel as a freestanding structure and as a cladding system. We look at the advantages of SIP panel over other methods of construction and what we believe is the advantages of using SIPs in offsite construction. So what are SIP panel? It's a make-up of a sandwich of 15 mm OSB with a high performance solid rigid urethane insulation core, and I will emphasise the 15 mm OSB because it gives it excellent compressive strength, racking resistance and we have a unique jointing method where the panels are rebated and then we have that insulated spline joint as you see there, and then when the panels are put together that gives you a continuous layer of insulation all the way through. Because unlike traditional methods like timber frame, we don't have any studs every 600 centres to make it stand up. So as I say, you've got that continuous insulation all the way through. We actually manufacture the panels in 1220 widths and they range from 4.8 up to 7.5 metres in length, but then they are processed to suit the individual project. They're processed on a CNC machine so they give you a very accurate and quality of construction. Because of the minimal timber within the panel, we only have probably about 4% timber content, so thermal bridging is considerably reduced compared to, say, to a timber frame or a steel, light gauge steel frame where you're looking at 15% plus. So there's minimal thermal bridging, so in turn that helps with the overall thermal performance. So the panels themselves can be used up to 4 stories as part of our BBA certification as a freestanding structure, or they can turn around and be used as an infill or as a cladding panel. And when used as a cladding panel, you could be looking at probably 50 to 90 mm thinner wall construction for a comparable U value. So in turn, that's going to give you more habitable floor space and potentially a better return on your investment. When it's used as a freestanding structure, generally the tech is used for the external envelope and also for the roofs, and that's down to a minimum 2-degree pitch. And with their delivery partners, they would then provide you with a full structural element. So they're providing all your internal walls, floor systems, etc. So you're ending up with a full structural kit that is then ready for someone to come along and put the external, internal finishes to. We manufacture 2 thicknesses of panels, 172 and 142. 142 will give you a U value of no worse than 0.2, and that does take into account the timber content within that panel, and the 172 will give you no worse than 0.17, and that is based on the new criteria for the BBA for declared lambda values. So as I say, it's taking into account the new process of calculating the U values. Not only does it offer excellent U values, it can turn around and address the issues with air tightness. This is an example of a project actually in Cambridge that was completed in tech, and this is a sample of the actual air test. So you can see there 0.95 air permeability through the structure. But that structure was just the tech building itself. There was no internal or external finishes. That was purely of the tech structure itself. Obviously the windows are in place. And that's because every connection will have some form of silicone or expanding foam into it. So it's aiding with the structure's air tightness through the fabric of the building. You're not reliant on a lot of follow-on trays to turn around and come and help you achieve that. Also mentioned, we've already mentioned that thermal bridging through the wall construction is minimal, which is taken into account when we do our U value, but we also have a suite of independently calculated psi values or PSI values based on our standard details. In the majority of cases are actually better than accredited construction details. So in turn that means you can create a very thermally efficient structure that potentially could turn around and reduce or admit your reliance on renewables, which in turn is also for the London plan will help you turn around and achieve the low carbon requirements a lot easier and a lot simpler. It's a very lightweight method of construction. The 142 panel is around about 24 kilos a square metre and the 172 is around about 28 kilos a square metre. So in turn that can help reduce your foundation loads, or you could turn around quite easily put on top of an existing structure. As I mentioned, you could turn around and be looking at a lot thinner wall construction, between 50 and 90 mil, with comparable U values compared to other methods, other systems. And the speed of construction is also brilliant. To give you an example on that, there was a school done by a contractor down in Sutton that was 2,600 square feet, and he reckoned it saved him over 6 weeks on his build programme. So that's considerable saving on his prelims that he had to turn around and do on that site. When it's used as a cladding system as well, you could turn around and probably be looking at 40 to 50% times quicker. And we do have a little animation here which shows how the cladding system itself works. This is showing it as a cladding, but it could quite easily be used as an infill. But when you're comparing this to, say, a light gauge steel frame system, I think this demonstrates how quick the process can be. As I mentioned earlier, our panels will be manufactured in 4.8 to 7.5 metres in length, so potentially you could be doing 2 floors in one sweep. There would be a bracketry system which in turn is fixed back to the frame, and then the panels will be fixed too. And as you see there, when the panels are connected together, there'll be a foam injected into that, and then they're nailed into position. So the panel itself is offering an excellent airtight structure. So as you see there, because the length of the panels we're producing, you could be doing 2 floors, as I say, in one go. So in turn, that's helping to speed up the whole build process. Let that catch up a little bit. So once them panels are in place, if you're joining two or three levels together, you do tend to have a bit of a flexible connection, because then that in turn is taking up some of the differential movement. But as I say, the panels will be, say, placed into place exactly the same way, foamed into position with the insulated spline joint, or if there is a need for any particular, some more loadings to be applied, a timber post could be inserted into that connection. And as I say, there's a mineral whirl or some form of flexible connection between each levels, which in turn is taking up that differential movement. We're showing an EPDM strip on this animation. Yes, on the horizontal joint it's probably ideal to help with the structure's air tightness, but we do really need it on the vertical joint because the panels themselves have been injected with foam, which is, as I say, aiding with the air tightness of the structure. And then once that's up, that is wrapped with a breather membrane, and then that is ready for your external finishes to be applied. And we go back to that 15 mil OSB, your rail system or whatever can be fixed directly into the face of that panel. You're not having to have any helping hand brackets, which in turn is going back to the main frame itself, and in turn is interrupting the insulation. So it's reducing thermal bridging, it's keeping the wall construction considerably thinner when you compare it to other methods, and it is also helping you speed up the whole build process. As you see here, because that 15 mil OSB provides excellent pull-out performance. There is a scheme in Stratford that we've been looking at, and we're looking at hanging a Danish clay tile off that, and that's around about 70 odd kilos a square metre. So you can see you can take quite substantial loadings off the face of the panel, and it eliminating all the helping hand brackets, as I say, which then means you've probably got to beef up the framework behind it. So you can then clad it with whatever method of whatever system you want to, whether it be brick, lightweight aluminiums, render systems, etc. This is just an example of how it's helping speed up the whole process. As you see, the panels have been inserted as it's working up the structure itself. Top floors are still to be erected, but the lower levels, the windows have already been installed. So in turn, that's bringing in the follow-on trade so much quicker. You could be, as I say, you could be looking at between 50 and 60% quicker erection time with the use of the tech system. And that's not just because of the tech panel, it's allowing the follow-on trades to be coming in so much quicker. The system itself is recognised by all the major building warranty providers such as your NHBC, Zurich, etc., because then that's on the back of our BBA European technical approval, which gives the system a minimum life expectancy of 60 years. And it's also LABC approved as well, and it's also Passive House certified. Alongside that, a couple of our delivery partners are also BOPAS accredited as well. So they've gone through some quite rigorous processes to turn around and become, as I say, BOPAS accredited. And we're also due to be undertaking our BS 8414 testing to enable the system to be considered more for high rise over 18 metres. That's a test that's coming up in the next couple of months, hopefully. System offers very flexibility. It's unlike your more what people recognise as a more modular structure where they come in set standards. Because the panels are processed to suit each individual project, it offers a lot more flexibility. You can turn around and it can be delivered in what we term as flat pack format. So you can see here, each panel is being processed in the factory on a CNC machine, offering high quality, accurate panels, delivered in individual components, which are then erected on site. Or it can turn around and be delivered to a delivery partner's factory where they erect several panels together. So it's delivering what they term as large wall elevations. So it can do a complete wall elevation and crane it into position. In turn, that's helping us speed up the build process slightly more. Or through one particular delivery partner, we can actually offer it in actual full modular units as well. So it has the flexibility to offer all types of methods, whether it's tight sites where you're struggling to get craneage into, or it can turn around and say be craned in quite large units if necessary. So it offers complete flexibility. Offers very predictable lead time, completion times as well, because the system itself is not affected by the weather. The OSB is an external grade board, so it's not prone to any water damage or water absorption because there's no end grain within the panel. The insulation is of a cellular nature, so it's not allowing the penetration of air and moisture through it. So we're not affected by adverse weather such as wind, rain, or as you can see in this one, quite extreme cold conditions. Correction can be continued all the way through. It also helps to turn around and close this performance gap that was highlighted in the Zero Cub interim report in 2014. What has been designed is what is actually being delivered. And a lot of the issues there was with additional timbers being inserted and air tightness. The tech structure itself actually helps you overcome that, because when it's designed, it's taking into account the thermal performance of the structure. The insulation is already in situ within the panel itself, so there's not waiting for additional insulation to be inserted. And it's also, you're getting what insulation has been specified, because that has been an issue sometimes. Is an insulation product could be specified, namely ours, but then substituted with someone else's product. But the lambda value through that is not the same, it's not equivalent. So in turn, you're not getting the same U value specification through that panel. It's also addressing some of the lack of site skills and understanding of the erection of the kits, because it's done through our delivery partner network who are using approved installers, so they understand how the structure goes together and the importance of that, the quality and the energy performance the SIP panel is offering you. We have minimal waste with the panels. As you can see there, that's just an example of a wall elevation, how the panels are all processed. They would be clearly marked up in the factory when they're delivered to site, so it's easy for the guys to put them together. If you can imagine, just like a big Airfix kit, you open the box up, there's your set of instructions, and you just follow them instructions, them plans, and it indicates where each panel goes. So in turn, that's reducing on-site wastage. I'll give you an example there of how minimal the waste. There was a 3-bedroom house that I was involved in. The only waste we had was enough to fill the boot of a Ford Fiesta. There was just a bit of packaging at the end of the day, because all the waste is in the factory. Any offcuts of the panels that we do use, we will turn into our insulated spline joint. If we can't do that, then they're put through a munging machine and then burnt, but that incinerator is actually providing power for the factory as well. So we don't send anything to landfill at all. And of course, as I say, the on-site waste being at such a minimum, that's reducing quite considerable costs. I think someone turned around and reported to me once over £1,000 a week for a skip in London. So it's a considerable cost to look at. Yeah. It's a lot to look at, isn't it? So the system itself can be used for residential, whether they be freestanding structures, as I said, up to 4 stories, or as a cladding system, and then clad with whatever method of a facade you want to use, or in communal projects such as education. The bottom one is actually a passive visitor centre at Telford, Shropshire. I was actually involved with that when I was at my delivery partner many years ago, and we actually saved the main contractor over £30,000 on that particular project, and gave him considerably more space to work with, because the original design was with a straw bale construction. How we're going to look to get to passive on that, I'm not too sure, to be fair. And as I say, through our delivery partner network, that's how the panels are delivered. They're guys who take on a great deal of responsibility, because they would be designing it, engineering it, and offering a high quality product that's delivered to site giving you predictable lead times, construction times on site, and handing over a complete structure that has been specifically designed and engineered for that particular project itself. And as I say, we have roughly about 20 of them. So we can offer a competitive tender basis as well, so you're not tied into one particular manufacturer. And it also overcomes a question that is often asked in these sort of events on off-site manufacturers. I get tied into a particular off-site manufacturer. What happens if they do go under for whatever reason financially? There's all that design work's been done up front. I can't take that anywhere else. In the very unlikely event of one of our delivery partners do go in, then them designs, you're still using the same specific system. Designs and engineering can be picked up by another delivery partner. So you're not having to undergo a complete redesign and looking at another system as you go forward. That is it. Thank you very much. Short and sweet, but hopefully it was all right. Thank you.